All right, well, let's go with the right answers to some more gas law problems. All right, there were 6 questions that you had to do on this. So, and they're all problems that you have to do. Basically, we come down to there's 2 equations that you need to be able to use. One is PV over T equals PV over T. All right, the other one is PV equals nRT. Those are the 2 equations. Now, I know you're going to be like, wait, there was like 3 gas laws. True, but if you remember in the notes, in the one set of notes we talked about, there's a way to get all 3 gas laws out of this one. All right, so we can utilize this one, and that one will give us all 3 gas laws. So, all right, well, first question, number 1, we got the pressure on 8.76 liters of anesthetic gas. Changes from 637 kilopascals to 273 kilopascals. What will be the new volume? The thing I'd like to see you use is, if you make the chart, like we talked in the notes, and you got system 1 and system 2, go pressure, volume, temperature. And we're also going to put down here N, which is moles. All right. And then what we do is we go through the question and put stuff in. Based on how many boxes and where the boxes are filled, that's going to tell me which one of these equations I'm going to use. All right. Let's number these. Let's say this is equation number 1, this is equation number 2. So I can reference that as to which equation we're going to use. Turn this a little bit so we can, okay. All right, so it says we got 8.76 liters, so that's volume. And then it says it's from 637 kilopascals, that's a pressure. And that changes to 273 kilopascals. It says wants to know what's the new volume, so wants to know this. Well, these other spots are all blank. That means those are all going to stay the same. All right, so we aren't involved with those. We're only involved with pressure and volume. All right, and there's 2 of them. Oh, so that means it's equation number 1. We got 2 pressures and volumes. All right, it's not equation number 2 because this one's only got 1 pressure and volume inside of it. Okay, so we're using the first equation, PV over T equals PV over T. All right. T, we're actually not going to use because notice T is out of the equation. So we really just have PV equals PV. So now we're going to put stuff in, and we've got pressure 637 times the volume of 8.76 equals a new pressure of 273 times V. And then from there we've got to divide both sides by 273. Am I still on the screen? Yep. 273 on both sides. That gets rid of that, so V ends up equaling, and I have this already calculated, is 20.4, and that's liters of gas. All right. Bring this over a little bit more again. All right. So that was the first one as to what you should have had. So let's go to the second one. We'll erase this stuff, so we're still going to use the same box. Second one says a gas with a volume of 180.3 liters. So we've got 180.3 liters, that's the volume. Got a pressure of 57 kilopascals. So we got 57 kilopascals is allowed to expand to a volume of 364 liters. So 364 liters. And it says, what's the pressure of the container? So they want to know the new pressure. We're still doing pressure and volume again, and temperature stays the same, so does moles stay the same. So we're using the first equation again, PV over T equals PV over T. Do I need T in this equation? No, I don't, so I can get rid of that. So I'm using PV equals PV. Put stuff in, 57 times 180.3. That's side number 1. All right, then we go to side number 2, and we have P, which is my X, times 364. So from there I got to solve for P, or X. Divide both sides by 364. That lets me get rid of these, and I get pressure, or X. And if you multiply this stuff out and divide it, then you should get 28.2. That pressure went way down because we made the container way bigger. So, all right, and that's my answer for that one. All right, question number 3. We'll get rid of all this again. I'm not even on time. Okay. All right, question number 3. We got a gas at 455 kilopascals, 455 kPa, and 25 degrees Celsius. Occupies a container with an initial volume of 4.7 liters. Ooh, now we got like a whole bunch of things on here. By changing the volume, the pressure of the gas increases to 535. As the temperature is raised to 125 degrees Celsius. And it says, what's the new volume? So once you know the new volume, so there's everything filled in. All right. Now the one piece, remember, degrees Celsius, we got to change that to Kelvin. So I got to add 273 to both of these. So this would be 298 Kelvin. Add 273 to this. That's 398 Kelvin. So those are the temperatures I'm going to use instead of Celsius. And because we've got two columns, we're using the first equation. So we've got PV over T equals PV over T. Now, can I get rid of anything? No. This time I got pressure, volume, and temperature. I got all three of them. So I'm going to put everything in. I got 455 times 4.70. So I'm just doing this column right there. Divided by 298 equals, now do column number 2. 535 times V over 398. All right. So from here now I'm going to cross multiply. We're going to go this way and that way. So I've got 298 times 535 times V equals 455 times 4.70 times 398. So now I gotta get V by itself, so we're gonna divide both sides by this 298 times 535. That lets me cross off the 298, cross off the 535, and I get V equals, and if you multiply all this stuff out, you should get 5.34. And the one thing I want to point out that you need to do when you type this into your calculator, you gotta go 455 times 4.70 times 398, then you got to press equals, all right, so that you get that answer. Then you need to put parentheses, so we're going to put all of this in parentheses and go parentheses of 298 times 535. You can't just go divided by 298 times 535, because otherwise it throws the 535 up above, all right. So this was 5.34, and we were talking volume, so that was liters. So that's the answer for that one. So that was number 3. I got 3 more of them. Whoops. Get to my page so I can get my answers. Okay. Number 4. I'm gonna get rid of all this. All right, number 4 says a 7.00 liter, so that's my volume, air sample at a temperature of negative 50 degrees Celsius, on negative 50 degrees Celsius. Has a pressure of 352 kilopascals, 352 kPa. What will be the new pressure? Well, there we can actually put that in there. That's my X. Wants to know what the new pressure is going to be. If the temperature is raised to 142 degrees Celsius, and the volume expands to 7.40 liters. Now we still got pressure, volume, temperature. So we are still using PV over T equals PV over T. And we're going to use all 3 of them because we have all 3 of them. I do got to change my temperatures to Kelvin. So add 273. So this is 223 Kelvin. Add 273. So this is 5. That's 11. That's 415 Kelvin. All right, make sure. Yep, okay. So I'm going to put these things in. I'm going to go pressure. So we're going side number 1 here. 352 times the volume, which is 7.00, divided by my temperature of 223, equals, now do side number 2. Well, we got pressure, that's X, times volume is 7.40, divided by my temperature, 415. All right, from there, cross multiply. So we're gonna go this times and that. So we've got 223 times 7.40 times P equals the other direction, 352 times 7.00 times 415. So from there, we gotta get P by itself. So we gotta divide by 223 times 7.40. That gets P all along. So we're gonna divide the same thing on this side, 223 and 7.40. That gets rid of that, gets rid of that, leaves me with the pressure. And if you multiply this out, you're gonna get an answer of 620. And we're looking at pressure, and our pressure unit was kPa. So kilopascals, so 620 kilopascals is the answer. All right, on to the next one. Where am I in time? Okay. You know what, looking at my time, we might stop there and make a part number 2. So let's do that. I'm gonna stop here. We'll see in part number 2 for the rest of the answers.